Hello and welcome to this week's edition of Labrats. So last week we had an experiment with glow sticks and we learned all about the different components of them and why they react in the way that they do, and that we learned that reaction was a catalyst. So I'm guessing that maybe we were so excited that we were dealing with glow sticks and how neat they are that maybe the lesson on catalysts could have potentially been lost, so I figured I would revisit it. So this week we're going to make something called elephant toothpaste, which is actually also a catalyst reaction. So this week in your lab kit you were given hydrogen peroxide and some yeast. And yeast itself is actually a really interesting ingredient. You use it in baking and whatnot, but it's actually a living organism. And we're going to come back to yeast later on, a couple labs from now, and discuss some properties of yeast. But for now, just know that it's actually a living organism, but we use it in baking. So this experiment is basically going to create a very vigorous reaction. So you should have a cookie pan because it is going to probably get everywhere. So you needed to provide your own bottle. So I have a bottle here, and you need to pour some hydrogen peroxide inside this bottle. So you've probably noticed in your experience through life that hydrogen peroxide comes in a brown bottle. That is because the chemical formula for hydrogen peroxide is H2O2. And if you've ever taken a little bit of science, you've probably learned already at this point that water is H2O. So it's a very similar compound to water. So the reason why this reaction works, or I guess maybe I should first say that the reason that hydrogen peroxide comes in a brown bottle is because hydrogen peroxide breaks down in sunlight and it actually kicks off one of the oxygens to become oxygen in the air and just water. So it's an unstable compound basically, and that's part of the reason why this reaction works. So you need to pour a little bit of hydrogen peroxide into a bottle, just like we've done here, just like so. And if you want, you can add a couple drops of food coloring as well inside, as I get it all over my fingers, inside, just to create, you know, a bit of a exciting color to your reaction. And then we're going to add a little bit of dish soap. Okay, so we are going to add a little bit of dish soap to this. So we're going to put a little bit of dish soap inside, and then we're going to swirl it around. Okay, just like that. So we have that part of the reaction set up. The next reaction, we are going to need a little bit of water, and what we are going to do is we're going to add our yeast to this water. So yeast will dissolve in water when you add it to it. So we're just going to pour this yeast in just like that. And then we're going to get a spoon and we're going to stir it up until all that yeast dissolves. So you can see that yeast kind of comes in these little, it almost looks like little balls, and it has a smell to it as well. These are good observations to be making. These are scientific observations. We are eventually going to come back to yeast and discuss it a little bit later in these labs, because we're going to use it for another experiment. And we're going to learn about, you know, just how exactly it's alive in that. So it's going to take a little bit of time to kind of break that yeast up. It really kind of tends to be sticky, almost like a sugar or something. All right, so that's about dissolved. So now what we're going to do is we're going to add our yeast into this container and we're going to see what happens. And then I'm going to explain to you why this particular reaction takes place. Just going to get a little bit more of this yeast off there. It almost looks like Pepto-Bismol. So the reason why this reaction happens is because yeast contains a compound in it called catalase, and we actually have catalase as well inside of our bodies. It's something that organisms have. This is really going crazy. It's something that organisms have inside their body to break down hydrogen peroxide, because we actually do naturally have some hydrogen peroxide that is produced within our bodies, but it's toxic to us, so we need to break it down. So when you add the yeast to the water, the yeast is basically sleeping. It's like hibernating, kind of like bears do or something. So when you add it to the water, it activates it and it wakes up. And then when you pour it into this bottle, what you're basically having happen is this yeast wakes up and it starts to break down that hydrogen peroxide and turn it into water and oxygen. Now the reason this produces so much foam is because of the dish soap that we added. So we can actually do this experiment again, and I'm going to show you what happens when you don't add the dish soap. So this is like a, you know, like a little example of how the dish soap is so important to this reaction. So what's happening in this reaction is the yeast is kicking off an oxygen from that, from the hydrogen peroxide. Remember, its chemical formula is H2O2. So it kicks off one of the oxygens and it becomes oxygen that gets released into the atmosphere and water. So we're going to be left with water inside of this inside of this bottle actually. So we're going to just do this again, open our yeast, which is the same yeast that we'd use to bake bread or make pizza dough or make buns or something like that. We're going to take our spoon here, we're going to stir up our yeast, and we're going to see what happens when we don't add the dish soap. Really, that's the only thing that I guess also the food coloring, but the important ingredient that we're leaving out is the dish soap. So we're just going to pour this in and we're going to see what happens. So we still get a reaction, but you can obviously see that it's just breaking down the hydrogen peroxide into water and oxygen, right? It makes a lot less of a foamy mess, right? But it still overflows and it still, you know, kind of gets the point across to you, right? It's just a little bit less pretty than this. So that is a catalyst. A catalyst is something that you add to a reaction to speed up the reaction, but it doesn't actually change the reaction. The hydrogen peroxide, if we were to put it in one of these bottles and just leave it, it would eventually kick off all of its little oxygens and become oxygen in the air and just water in the bottle. That reaction would happen naturally, just having it sit out in a bottle that isn't brown. But what we do when we add the yeast is we actually just speed that reaction up. It doesn't change the reaction, it just speeds it up. So that is what a catalyst is. A catalyst is something that you add to a reaction to speed it up. Chemists use them all the time because there's some reactions that take place just so slowly that it would almost be impossible to witness them without actually having sped them up somehow. So it is a very important thing. If you go off and take, you know, university chemistry or take it in high school, you're going to learn all about these types of things. So it's an important thing to kind of understand. So there you go. You can perform this experiment as much as you'd like. It's really fun. It obviously produces some pretty great results. And if you have any questions or comments, you can leave them in the comment section of this video, and I'll see you guys next week.